Crown jewel of modern science. 25 centuries of guesswork and experiment form the road to our modern, elegant model. It's hardly surprising to find the road signposted by some of the brightest names in the history of physics. But one name we don't know is the name of the person who first asked, how big is small? Can things be broken in half forever? Or can we eventually find something so small it cannot be further divided? The question lies at the root of all matter we see around us. Alas, history does not record the first person to ask this profound question. The first record of a reasoned approach to the structure of ultimate smallness was proposed by the Greek scientist Democritus, who lived about the 4th century BC. Democritus proposed that all of existence is comprised of two things: atoms and the void. The word atom derives from the Greek atomos, which means indivisible. This concept became known as atomism. How do his ideas stack up today? All reality is made of particles in space. Atoms have motion. Atoms are indivisible. Existing things differ from each other because of the shape, arrangement, and position of their atoms. Every event results from a collision of atoms, and therefore can, in theory, be predicted. Not a bad score for a philosophical idea with no supporting evidence. Unfortunately, Plato and Aristotle, who were more popular philosophers, pooh-poohed the concept of atomism. And perhaps because of Democritus' idea that the human spirit could be explained by soul atoms, atomism earned the full and awesome opposition of the early church. The search for an understanding of ultimate smallness languished, practically unattended, for nearly 2,000 years. Not that activities came to a halt altogether. The practice of alchemy spreading westward from China and India took root and sprouted in the West. The alchemists were fascinated with a grab bag of life's great mysteries, along with such mythical processes as transmutation, the changing of common metals into silver or gold. Believing that all matter is a single formless substance, the alchemists added little to our understanding of the atom. But they shifted the study of nature away from the Greek idea of pure thought to include the concept of observation and experimentation. The alchemists had unwittingly discovered a path which led from the Greek ideals of pure thought toward a more modern scientific method of investigating smallness. For many centuries, few dared to erect a clear signpost. Roger Bacon, 1214 to 1294, attempted to set forth a formal system of knowledge of nature based firmly on observation and experimentation. Like many others, Bacon was intimidated by Orthodox religion and decided not to publish his findings. But by the reign of Elizabeth I of England, experimentation was, if still blasphemy, at least becoming fashionable. Philosophical scientists are men of acute intelligence, but without actual knowledge or facts, they slip and err. William Gilbert backed up his opinions with a book of carefully designed experiments which formed the foundation of magnetic science. Among other things, Gilbert demonstrated that many different materials, when rubbed, have the ability to attract small bits of matter. Although Gilbert was not searching for ultimate smallness, the forces he and others observed would prove to be fundamental to the structure of the atom. Niccolo Cabello was soon to discover repulsion acting in a similar manner. In 1792, Benjamin Franklin performed his famous kite-flying experiment and showed that lightning is electricity, which he believed to be a fluid. He called an excess of fluid positive and a deficiency negative. In 1785, Charles Augustin de Coulomb established Coulomb's law, which states in part that the force between two electric charges varies inversely as the square of the distance between their centers. These findings would be central to experiments which first pointed out the true nature of the atom's interior, more than a century after Coulomb's death. While the works of these early investigators may not so far appear to bear directly on our understanding of the atom, a complex mosaic of knowledge was developing. France provided the next pieces. Antoine Laurent Lavoisier formulated the law of conservation of matter. Lavoisier designed a combustion apparatus in which hydrogen gas and oxygen gas could be brought together in a chamber and ignited with an electric spark to form water. In June of 1783, he demonstrated that the mass of the reactants equals the mass of the products. His experiments suggested that matter was concrete and measurable rather than magical and did not simply vanish in a chemical reaction. Finally, Joseph Proust proposed that the enormous variety of chemical compounds was made up of a few simple kinds of building block matter, or elements. These elements combine in constant proportions to form a particular compound. This law of constant proportions, together with the law of conservation of matter, led to the work of this man, the English chemist John Dalton. Dalton would merge the classical speculations, the metaphysical wanderings, the scattered discoveries of 2,000 years into the first modern theory of atomic matter.